Bismillahirrahmanirrahim. Assalamu alaikum student. This is your chemistry teacher Farzana Nazir. Today we will continue chapter 5, that is physical states of matter. Today we are going to study boiling point, temperature vapor pressure curve. We are going to study effect of external pressure on boiling point. We will determine the boiling point of an organic liquid. We will also study the difference between evaporation and boiling point. By the end of this lesson, students will be able to understand the concept of boiling point. They can easily explain the effect of external pressure on boiling point. They can interpret the temperature vapor pressure curve. By the end of this lesson, they will be easily differentiate between evaporation and boiling point. Students, you have already read about the two important properties of liquid, that is evaporation and vapor pressure. Today we are going to discuss the third property of liquid, that is boiling point. Before going into further detail, let us find out what is boiling and how does boiling take place. In an open container, atmosphere exerts pressure on the liquid surface. When a liquid is heated in an open container, average kinetic energy of the molecules increases. Therefore, the temperature of the liquid also increases. Heating allows large number of molecules at the liquid surface to overcome the attractive forces responsible keeping them in the liquid. This increases the vapor pressure of the liquid. Vapor pressure of the liquid keeps on increasing with increase in temperature. At a certain temperature, vapor pressure of the liquid becomes equal to the atmospheric pressure. At this stage, liquids start boiling. The bubbles of the vapors form throughout the liquid, rise to the surface and escape into the air. Boiling point. Temperature at which vapor pressure of the liquid becomes equal to the external or atmospheric pressure is called boiling point. Temperature is directly related to vapor pressure. It means greater the atmospheric pressure, greater will be the temperature at which the liquid boils. Because greater the atmospheric pressure, liquid will require more energy to overcome the attractive forces between them and escape as liquid. Different substances have different boiling point. For example, boiling point of chloroform is 60 degrees centigrade, boiling point of water is 100 degrees centigrade, and boiling point of ethanol is 80 degrees centigrade. Now, boiling point is different at different levels. At sea level, atmospheric pressure is 101.325 kilopascal, or which is equal to 1 atmosphere. So at this atmospheric pressure, water will boil at 100 degree centigrade. Now at Mount Everest, water boils at 70 degrees centigrade. This is because at Mount Everest, which is about 8,850 meters above the sea level, atmospheric pressure is only 34 kilopascal. So, water boils at this height above sea level when its vapor pressure is 34 kilopascal at 70 degrees centigrade. So, water boils at 70 degrees centigrade at Mount Everest. Water boils at 120 degrees centigrade in pressure cooker. Why? To find the reason, let us watch a video. Pressure cooker is equipped with a valve that controls the pressure inside the pot. These valves generally exert a pressure of 2 atmospheres. Therefore, the valve does not allow water vapors to escape until the pressure inside the pot reaches 2 atmospheres, because vapor pressure of water becomes 2 atmospheres when the temperature reaches 120 degrees centigrade. So, water boils at 120 degrees centigrade in pressure cooker. Now, a question may rise in your mind that can you make water to boil at 70 degrees centigrade at sea level? As you already know that at sea level the atmospheric pressure is 101.325 kilopascal. So at this atmospheric pressure, water boils at 100 degree centigrade. Since boiling point is directly related to vapor pressure, therefore by lowering the vapor pressure, the boiling point of the liquid can be lowered. So in order to boil the water at 70 degrees centigrade, the atmospheric pressure should be less than 101.325 kilopascal or 1 atmosphere. While camping at the elevation of 0.5 kilometer in the mountain, you will find that it takes longer than it does at home. Explain why. At high altitude above 0.5 kilometer, atmospheric pressure is low. Water boils below 100 degrees centigrade. At this temperature, since the heat content absorbed by the water is low, therefore there will be no much heat for the eggs to cook properly. As a result, eggs take longer time to cook than it does at home. The boiling point of water on top of the Mount Everest is 70 degrees centigrade, while at Murray it is 98 degrees centigrade. The reason for this is at Mount Everest, which is 8,850 km above the sea level, the atmospheric pressure is only 34 kilopascal. At this atmospheric pressure, water boils at Mount Everest at 70 degree centigrade. Since boiling point is directly related to vapor pressure, as we come down the height of a mountain, the vapor pressure gradually increases. So, at Murray, which is at lower height than Mount Everest, atmospheric pressure is greater. than 34 kilopascal. Therefore, water in Murray will boil at 98 degrees. Boiling point of a liquid is the temperature at which the vapor pressure of the liquid becomes equal to atmospheric pressure. At 1 standard atmospheric pressure, the boiling point of liquid is termed as normal boiling point. Different liquids have different boiling point depending upon difference in intermolecular forces present in a liquid. Now let us calculate the boiling point of an organic compound, that is toluene. Materials required are paraffin liquid or water in a beaker, toluene, test tubes, thermometer, capillary tubes, dropper, rubber band, stirrer, stand, Bunsen burner or hot plate. Procedure: place some amount of liquid in the fusion tube and tie it with thermometer with thread or rubber band such that the end of the fusion tube and thermometer are equal. The rubber band should be fixed near the mouth of test tube. Place the beaker containing water on the stand. Suspend the thermometer along with fusion tube in water in such a way that they does not touch the bottom or the side of the beaker. Now take a capillary tube, seal one end of the capillary tube, place this capillary tube in the fusion tube, open end is dipped in the tube. Heat the beaker and stir water with the stirrer to ensure uniform heating. Continuous heating and stirring until bubbles start rising from the lower end of the capillary tube. After some time, a continuous stream of bubbles start to escape from it. Note the temperature T1 when continuous stream of bubbles start. Note the temperature T2 when the stream of bubbles has just stopped. Now the boiling point of toluene is the average temperature T1 plus T2 over 2, that is 111 degrees centigrade. Precautions: the capillary tube should be properly sealed. The rubber band should be fixed near the mouth of the test tube so that the open end of the test tube with the rubber band is sufficiently outside the liquid paraffin bath. The liquid paraffin bath must be heated very slowly and the bath is stirred gently to ensure uniform heating. The open end of the capillary tube should be well inside the liquid. Now let us discuss the difference between evaporation and boiling point. The first difference between evaporation and boiling is that evaporation is a surface phenomena. As you already know, it takes place only at the surface of the liquid, whereas boiling is not a surface phenomena. It is a volume phenomena in which whole the water start boils. Second difference is that evaporation takes place at all temperature, whereas boiling only takes place at specific temperature. For evaporation, source of heating is not required, but for boiling, source of heating is required. In evaporation, bubbles are formed at the surface, whereas in boiling, bubbles are formed throughout the liquid. Evaporation is a process which causes cooling, whereas in boiling, cooling does not take place. Evaporation is a slow process. Evaporation is a slow process, whereas boiling is a fast process. Example of evaporation is drying of cloth when they are hanged on a wire. And example of boiling is the boiling point of water is 100 degree centigrade. Now let us have a quick review of what we have studied today. Now let us have a quick review of what we have studied today. The temperature at which the vapor pressure of the liquid becomes equal to the external or atmospheric pressure is called boiling point. Temperature of the boiling point is directly related to vapor pressure. At sea level, atmospheric pressure is 101.325 kilopascal. Therefore, water boils at 100 degrees centigrade. At Mount Everest, atmospheric pressure is 34 kilopascal. Therefore, the boiling point of water is 70 degrees centigrade. In pressure cooker, water boils at 120 degrees centigrade because the internal pressure in the pot is 2 atmosphere. I will give you some questions which should be solved in your own words, and the answer should be very brief. Question number 1. Can you make water boil at 70 degrees centigrade? As I have already told you that the boiling point of the liquid is directly related to atmospheric pressure. Higher the atmospheric pressure, higher is the boiling point. Lower is the vapor pressure, lower will be the boiling point. Question number 2. Water boils at 120 degrees centigrade in pressure cooker. Why? I hope you have understood the procedure which is taking place in the pressure cooker. Try to answer this question in your own word. Question number 3. Explain the effect of external pressure on boiling point. Now, last question is about a graph